Today we're going to make a summary about the study of rollovers of vehicles. And I have this video on a two-dimensional rollover of a video of a car, also of a three-dimensional one. And we should take a look how we can put together this test and how we can actually execute on the to find out the forces that are generated during a rollover. So let's take a look at the video that I have in front of us in here, and then we'll look at the 3D. So let me disappear here. Let me play this. This is a vehicle that is skidding sideways and finds an object that cuts the tire in there. And the vehicle, this video is made in very slow motion so that you can see that the vehicle does one roll in the air before it falls down. And when it falls down, watch the graph up there. You see that peak? You have two green peaks. One on the left is the object that hit. The second one hits on the suspension. The third hits on the driver's side. And those forces, this is a vehicle that weighs only 2,500 pounds. So you could see the first force on the suspension is close to 8,000. The one for the roof is 5. No, around 4,000. But we haven't, it hasn't completely stopped, but the energy is being lost as time goes on. And obviously and the energy is the least. Um, and the energy loss is the least on the last roll. Finally is gonna settle down and just skid for a little bit. But the point of this whole simulation is that you can predict the forces that are in the system. Like in this case, let me show you on the how it looks in the modeling software. It's the same thing, but now running it live. See, this would be in real time. So the point here is that we could take a look at the forces that are in there, and you see there's the first hit on this object on the sidewalk or on the ditch or change of pavement, you could say. And here, this is the big the first hit on the suspension. This is the collapse of the roof here, and then of course in other parts of the vehicle until later. So I will reset this and then run it again for you. This is in real time. So I run the video in slow motion and now in real time so you can see the difference. But you see this rollovers are controlled by the laws of physics, by the change of the angular momentum of the vehicle due to the impact forces on the ground. So if it starts with an initial momentum, like you see in here, and then slowly with the impact forces on the ground, the momentum is lost to the point that the vehicle stops. So during the first roll, you have the maximum loss of energy, the maximum deformation of the roof, and that's where the injury occurs. And on the last roll, then you don't have this. It will dissipate all. But if anybody tells you that the person gets injured on the last roll, you could see that that's not the case. person gets injured on the first roll because it's the maximum amount of energy that is lost. So to understand this principle in here, I have another simulation in here, or a basic problem here that you see. There is a box in there on the just laying on its side, I would say on one of the edges. And the idea here is, can we predict how much the box will, what the impact forces will it be if we just let it go by itself? Keep in mind that in the case of the rollover vehicle, the vehicle had initial velocity. In this case, we are making it that it doesn't. So to see what would happen if you just roll the car, and just roll. So suppose like the car is upside down now. It's just gonna begin rolling on its roof, and let's see what happens. So if I click on run, very slowly the box will turn to the right, and then given the coefficients of friction and given the velocity with which it it um, it goes, then we will produce the velocity and the forces. So we are able to calculate those. Let me just do a reset so you can see it. So it will very slowly turn to the right and then accelerate and then finally goes up a little bit and stops. But that would be the kind of things that we can find out are the velocities and the forces. But if we take a look at the rollover tests on this in 3D, we have the situation like this. Okay, we have the vehicle there, and then does a J-turn, and then it goes. So this is to simulate it in real time. They said this vehicle start rolling over at 42 miles an hour. So, okay, so we have in here roll, and then it rolls over. The idea in this case is that the driver made like a J maneuver, and then the vehicle skidded on the back, hit the suspension system, hit the side of the road like we did on the previous one, like this one. When it hit the side of the road like that, then it roll over, see? And that's the 3D is simulation is complementary of this one. So the idea in 3D was to find out in more detail, but pretty much this gives us a good idea of what went on. So here, this is the 3D. And the question is, how do we put that all together? Let me see if we can run it in slow motion. It's a little slower. I think that way you can see what's happening. So we go like that. Yeah, that gives you a chance to see it a little better because in real time is fast. So how do we actually develop this? This is This is a Ford Escort 1989, and you see we took a look at the parts from the actual vehicle, how the suspension on the back is made, and went ahead and actually modeled these parts to put together the system. This is the vehicle as we found it on a junkyard. And of course, the Ford Motor Company was not about to give us the specifications of the dimensions or anything of that suspension. So we went ahead and found that from another vehicle. Based on this, the parts started being developed the way we have done it in this class for the past several weeks. Put together all the different parts in SolidWorks, the control arm in this case, and the stabilizer bar, all these different parts to put it together on the system to assemble the suspension for both the front and the back. So that's the way the system was developed. But if we look in detail on the suspension, we could actually look in our model over here. We could actually look at it in pretty much detail. Here you see it's let's see, let's modify this. Okay, and I'm just gonna get the vehicle here so that you can see how detailed the suspension of this is. So we're gonna go on and basically put the vehicle on the opposite side. Okay, so we just turn it around, but you can see how from the junkyard parts and the precise measurements that were done, we were able to develop the suspension system of the vehicle. And that's what you see on these pictures right there. So I encourage you to do the same for your vehicles, to do it at the same level of detail. And if you do a simulation of a rollover, you have the details of this one so that you can actually build your own. Okay? But the suspension system was only one test, but we also look at the drop tests. And the drop test on this car, let's go take a look in here. This is the drop test from 1 foot. And so the idea is to measure the impulsive force here, which we looked in here at 670 slug feet per second in 0.08 seconds. See, we can look at that from this and measure the time as well. So if this is the case, we're looking at about 8,375 force. Now let's just think about this. Car weighs 2,500 pounds, right? The roof is supposed to, according to the US standard, 1.5. So can you do the calculation? 2,500 times 1.5 is what? About 3,700 or something like that, right? So when we see a force like this, there's no chance that that roof would not cause injury to somebody inside the car. And then you have this in here drop from 1 foot to look at the different values. If you drop it from 3 feet, the force jumps to 14,370. And this is, of course, the different tests that were done on this at different angles or different drop tests. But this is something you can do also for your vehicles. And I think we might have an ABI model of this. Let's see, this is the, okay, this is the actual drop testing here. See, this is how we do it. And that you can keep track of the impact forces this way. Okay. I think I showed you the different ones that we have, and so that you can see that from the 3 feet we can do the different tests, and also for 1 foot. But nevertheless, the conclusion is that based on the test that we have done in here, the roof basically collapses even at 1 foot of drop test on this car.